So what we'll be doing in this video is going over how to create a waffle slab ground floor with a column system. I will be starting with a simple exercise using a rectangular subdivision, and at the end I show you how to create it using a triangulated pattern. So thank you very much for being here, and let's jump into the tutorial. If you want to get a hold of the script that I'm using in this video, check out my website capettidavid.com. Under the free resources tab you can find the script for free. And then if you join the Vault membership, you'll be able to access all of the resources as well as get in touch with me for any particular questions. So to start, the first thing we need is the base geometry. And typically, if you have a floor slab, it's going to be in a regular size or geometry. And for this one, we will be using a rectangle. So I'll go here to a rectangle component and I'll give it 2 sliders. So I'll click here for 30, from 0 to 100, it sets it at 30. And I could do the same thing for the Y size. Now the next part is going to be locating where the columns are going to be, because typically when you create a waffle slab, you will have some places where the columns or the slab is going to bear on the columns. So we need to create those. That way we can eliminate that part of the pattern and we can create the columns in that location and create the rest of the pattern on the rest of the base geometry here. So let's create some columns at those locations. So I'll go to rectangle, and then here I'll go to divide surface. Now we have different locations here where we can pick the specific place where the columns are going to go. So now we'll go to the number of divisions. So we'll say 5 in the U and 5 in the V. And typically when you have a slab like this, you don't want your columns all the way to the end. So this is where we could offset an overhang. So we'll offset this rectangle in the negative direction because we want to maintain the outside face dimensions. And now we can offset this to the inside, and I can give it a value of, let's say, 3.5. This way we can offset 3.5 to the inside. And now this is where we'll be creating our subdivision. Now, if we don't want the same subdivisions in the X or U and V, we can change that. Now, this is going to determine our subdivisions for the columns that will support the slab. So now at these points, we have 20 points. At those points, we're going to create some boxes. So I'll go here to rectangle. We'll move these points, or we'll be using those points to create the rectangle. And now we can give it the value for the column size. So 2.5 for a slider that I can create 2. And they're a little bit large, so I'll just go here to 1 and 1. What happens is it creates it from the point up positive and then positive. So we can go half negative and half positive. That would be one way to do it. Or the way that I like to do it is just moving it in the opposite direction halfway. So this is a technique that I use. There are other ways of doing this. I just prefer doing it this way. I'll use a rectangle as a geometry input. Now we'll move using a vector. And the vector is going to be X and Y are going to be plugged in. Now if we move this again, well, it's going to move to that other corner. But if we go divided by 2 in negative direction, we're actually centering it. Because every time this increases, it will still maintain that center point. Now we can disable the preview on this, And if you wanted to, here's where you can create a cluster for a centered rectangle. So this is how you could do that. Within the script, this is going to be the size, this is going to be the rectangle, this is centering it on the point, and now we have a geometry component out here, and we can take all of this information in here, middle click, and create a cluster from it. So this is going to be, this cluster would be labeled So this is how you can create your own custom component. Is this one is going to be the U and V size. So I'll go here to U. This one's going to be V. And these are going to be the points. And the output is going to be the rectangle. So this cluster that I just created is nothing more than rearranging this rectangle or square to be centered here. And we can do that with any other point. If I took this point and I brought it in and I said set 1 point, now this is where it will create a rectangle exactly in the center. So notice that it can do that with anything. And I'll probably have this on my website under the free portion. So you can just download the rectangle from center. That's actually one that I use all the time. So now with this, we're going to eliminate that from the pattern. But we need to do a few steps before this to create the waffle design. And then we will be subtracting it using this pattern. So at this point, we have our slab, we have our columns, which can change. And now we need to create the pattern. So now we can forget about this stuff for now. Go back to the original, and now we'll be subdividing this with isotrim. So now let's do that. Let's take this rectangle and go to isotrim. Just know that I'm using isotrim because it divides it in a rectangular pattern. Now there are other patterns that you could use, and that would be by downloading something like Lunchbox, and Lunchbox will have the ability for you to create all of these patterns just with one component. This one will have to use isotrim and divide domain squared. And I do like to use a relay for this because now we can organize it like this. So the surface or the rectangle comes into the relay. The relay is a mini component that holds that information. Now we can use that as the input here and the input here. What happens is it's a rectangle, so it's not going to divide it until we do boundary surfaces or planar surface in Rhino. We can use this and this and change the U and V. So I'll go to 5 and 5. And it doesn't necessarily have to line up with this unless you want it to, right? If you wanted to, you can say 3 and 4, U and V, and we can tie those together. And therefore, it will tie that information, but you actually have to add 1 because we have 1, 2, 3, 4, 5, and we only have 1, 2, 3, 4. So either we add 1, which is plus 1, because now it has 1 extra subdivision. And we can do plus 1 also in the U count. So this is how we can tie it to those, but we actually can't tie it to that because the column doesn't even land in the center there. So I would say create your own waffle slab pattern here, depending on subdivision. So it could be twice as much as that. It can be whatever pattern here. And it will be subtracted from where the columns are. So now that we have this surface, now we can create the waffle. Actually, no, we need to create the pattern here. So let's go here to this one. Now with this, we will actually offset to the outside because we don't want the waffle slab to go right up to the columns. We actually want it a little bit to the outside. So. All right, so at this point, we have the offsets. Now let's disable the preview on that original boundary surface. And let's subtract these offsets from the overall. So I'll go to region difference. And we'll use this for A and this for B. Now we do have to flatten the input so it takes care of all of them at once. And now here, you'll see that if we disable the preview on this and we do a boundary surface on this, now we have removed where those columns are and they can land anywhere. So now here, what we can do is with our leftovers, now we need to go to the center of each and create the pattern that we want. So if we want, we could take this and offset this to the inside. So we'll go to offset, curve. We'll be offsetting. It automatically goes to the outside. So we do have to bring in a negative and then a slider. This is too much, something maybe like this, right? Where it's 0.3 offsets here. And now we're going to go another offset to the inside. So I'm taking this, tap Alt. Now we'll be using this output as the input. So now we have 1, 2, and 3. So what we need to do is we have this boundary surface. Well, now we can remove this region on the inside. So region difference, we'll use the slab and subtract the offsets. Flatten the input so it does them all at once. And now we need to create a boundary surface between the two. This is where we do another boundary surface. And we can disable the preview or delete this component. So this from the bottom is going to look like, okay, this is concrete. And now we're going to start tapering up. So this is where we take this and we move this up. So we'll go to move. And depending on how thick your slab is, in the Z direction, and we can just say 1.50, so we have a little bit more control with the decimal point. Now we're at 0.5 here. So we have moved this up. Now we need to loft it together. So I'll go here to loft between this offset and this. But we need to, let's see if flattening the input. No, it's going to be graphed. So what happens is this information is coming in grafted, so is this, but for some reason, it's giving me an issue here. So I'm unplugging this one, holding down shift and plugging this one in. Here's the thing that I noticed is if you offset by 0, this is coming out of an offset component and it organizes the information different than when you move it. So if I take this and I offset, distance, I'll just set a number of 0. And this is an offset. And if we loft those two, it will work. Huh. For some reason, these are not working, and it should work. So let me try this. Load this one. Load this one. And loft these two. Using graph tree. So let's try that. So it's doing it when I do it up like this, but not when I take this and I offset it. If I offset it again, and I use that instead, So the idea was to, rather than, yeah, so I haven't figured that out yet. I need to figure that out. First, we'll loft these two and then just create a boundary surface between. Actually, this one first, and then this offset. So the simple way of doing it for now, I'm going to just do it this way and move on, is going to be extrude this up. And then when you extrude that up, then you also move it up and create a surface at that top location. So this is something I want to come back and fix, is allowing this to taper. And there could be other ways where we can chamfer the edge between this and this. So this edge, we can chamfer it. That could be another cool thing that can be added. But these two will be joined. A B-rep join between this and this. Flatten the input, disable the preview on everything else. Now we'll join it with this one. Now here is the other critical thing. This is going up by 0.5, but it can go up by whatever. So whatever this number is, when you add on top, that's going to be your floor slab thickness before the subtraction. So what we'll need to do is go here to this rectangle and extrude this base rectangle by this plus the slab thickness. So if I said the slab thickness is 0.5, it's this much plus 0.5 by how much we want to extrude this up. And And now we can take this and use a move component rather than an extrude and move the original polyline up. So this polyline, this rectangle, is going to be moved up to that location, and then boundary surface to create a surface and close off the entire slab. So with the top, the side, and all of this joined, now we can take care of the rest. So join the top, the side, and the rest of the design. Flatten the input and disable the preview on all of this. And now we have one last thing, which are going to be this rectangle, which is based off of the original rectangles, then offset. Now this is going to be boundary surfaces, and we'll join this as well. So the cool thing about this, and I know there were some places where I wanted to show you something else, but I still have to figure that part out. The important thing is we have the location where the slab or where the column touches the ceiling. Then the subtractions for the waffle slab, and then at the top, it's going to have the thickness for the floor slab. So let's go and take our original rectangles and extrude them down to create the columns. So we'll go to boundary surfaces to create a boundary surface at those columns, and we'll extrude them down. So negative Z direction. We'll do 10. The slab thickness is going to be here. So 0.5 between here and here, and then we can say even 1 above that, or you can say 0.6. So 1 foot, and then 1 foot for that. And here, now we can take this and the columns, bake it, and I'll move it here to the side. I'll go ahead and bake this here. And let's go to shaded mode. We'll see. And this is something that can be done after the fact, but if you do chamfer edge and you said 0.3 and then face F for face edges, you can pick these. I'm just going to do this row. And kind of create that additional chamfer for the top. So this is how useful Grasshopper can be, not just for crazy architecture, but for practical things like this. And you can also just, if you don't want that many columns, we can come back here and decrease that. So we have more divisions. So let's say 10 and 10. The cool thing is that it does it all at once here. It's going to calculate. It's going to take a little bit to calculate, but once it calculates, you'll see that it'll take care of it. And let's decrease the number of columns. Okay. So here, bake. I like to kind of bake it here to take a look at what it looks like inside. So in here, layer 1, flipping plane, vertical for a section. And we'll see so this waffle becomes its own column and rafter system. And the slab here at the top is going to be this monolithic slab that holds the second floor. So what I've done here is just using isotrim, I was able to create these patterns, subtract them from the columns, and that's going to kind of conclude the exercise here. Let's go back here and organize this a little bit. And this offset is going to be the overhang. And pattern. So that's the column offset from here. Then this. This is going to be the depth. And what I like to do is group these together. So each slider kind of gets a group as long as they're the ones that kind of change the design. And this way, I can kind of know with just visually which ones are the ones that I want to change. It also makes it easy when you download the script to see what's going on here. Here are the things that are running through my head right now. And sometimes while I'm cleaning this up, I come up with some things to share with you. First thing is that this is a rectangular pattern. You can use any pattern. I also thought that you may not need to subtract the column location here, because what we can do is where that point is, we can just create a box that intersects with whatever pattern it is, and therefore it won't overlap. So I already have some further ideas that we can do with this. So I'll group this for the columns, group this for the slab. And that will do it for this one. Now I do want to try that. I'm actually going to try that here at the end. I'm going to, basically we finalize this as our exercise, but I do want to try out creating this not as an extrusion, but as a triangulated, like these will be extruded to a point and still be able to keep the information like this. So stay tuned for a bit of a different iteration, but this will conclude the overall steps where I want to show you here how to create a waffle slab. So thank you very much for being here, and I hope to see you on the next one.